Good morning. I'm going to try to prove the Pythagoras theorem, as you can see from the picture here. Let me get my pen here started. All right. First thing is you notice right here is that the Pythagorean theorem states that in a right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Okay, the hypotenuse is always the long side. Here's the long side right here. And then the other two sides, which is this side right here and this side right here. And you notice if I square this is actually 1, 2, 3, 4 squared. It's going to be 16. Likewise, 1, 2, 3 squared is going to be 9. And you add 9 plus 16, you get 25. Okay, that's essentially what the theorem talks about. Well, let's try to prove that by another means, if I can get this little system here to work, is that I will draw a triangle right here from here. All right, we're going to go from here down and then over to here. Okay, that's one. Then I'm going to go over from here to here and then down to here and then down from here and then down over to here. Okay, now that is our, so what I have done is drawn this area right here, which is a square, which is 25, which is 5 on each side, okay? And what I'm going to do is label these, if I can, right here, is I'm going to call this side right here A, and this side right here B, and this side right here C. Okay, so what I've done is put this triangle here, which is the B, which is 3 units long. I'm going to make this a B. We've already know this, right? This length right here is A. So from here to there is A. From there to there is B. And likewise, from here to here is going to be A. And then from here to here is going to be B. Remember, that's going to be just a little bit shorter. This is A. And this is B. And this, oh, that's right. And this is A. Okay? And this right here is C. So what I'm going to do over here is draw a little line right here, and we'll make some statements and things right here. Okay, first statement, okay, is that what we want to do is first thing we want to do is prove that c squared is going to equal to a squared plus b squared. All right, and what we are doing, we are given, all right, we are given that we have this AB, the sides of AB and the C's. All right, we're given those. All right. So the first statement is that what we want to do is now we want to find the area of this. What the strategy is to find the area of this entire square here. All right, and then we find the area of that square, then we will find what the elements of that area is, you know, in other words, by using partition. So the goal is to be able to do that. For the first thing is I know that A plus B squared is going to be equal to the area of the entire square. All right, it's going to equal to the area. All right, and that's, how do I know that? Well, because that is the definition of area of a square. Okay, I also know that based on partition is that if I add all these different elements up in here, it also will indicate the area of the square. And so I'm going to put down here by partition. All right. And so I'll know from that is that to find the area of this triangle right here is what? I've got 4 of these triangles. All right. So I've got 4 of those triangles times the area of a triangle is 1/2 the base times the height. So that'll be 1/2 AB, right? AB plus, so I got 4 of those, and then I've got the area here, which is going to be c squared, correct? So that'll be c squared. So that partition right there, I'm going to find out the area of this, and that's going to equal to A. Since I know that A equals A, then by substitution, I know that this right here, that I know that A plus B squared is going to equal to 4 1/2 AB plus C, all right, and that's squared, all right? Now, I'm going to go over here for a second and then work this out. So let's expand this. So A squared plus B squared is going to equal to A squared plus 2AB plus B squared. And we know that's going to also equal to this over here, which is 4 times 2, that's going to end up being what? That's going to end up being 2AB plus C squared. Okay, so from that, and the reason I can do that, all I'm doing is I'm simplifying my that's difficult to write with this, simplifying this equation right here. And from that, which I'll bring essentially all of this right here, all of this goes to right here, all right? Then, what can I do? I can subtract 2AB from both sides, correct? 2AB from both sides, and these will cancel out, and I'll end up with A squared plus B squared equals C squared. And I did that by subtraction. TTION. And therefore, we have just proven right here that C squared equals A squared plus B squared. Now, of course, I can swap these over by using symmetry to make this just like this, using symmetry to really make it exactly the same, squared plus B squared, and that's using symmetry. Symmetric property. Okay, so that shows you then how we have just proven Pythagorean theorem by using this right here, and you can see that these triangles, added these other triangles together, is going to equal, and plus this, it's going to equal to that whole area that we just did. Okay? Thank you so much. Have a good day.